talk about arc length of a circle and derive a formula that'll play a role later on in this course. It's the way to measure the length of arc of a circle. So here's the setup. Consider a circle of radius r. So here's a picture of a circle of radius r. And suppose the angle theta corresponds to the arc length s. So as I said earlier, it subtends or cuts off an arc of length s. How big is s? What's the length s? Well, we can derive a formula in terms of that angle and the radius. And this will be as follows in radian measure. The full circle is 2 pi r, but we're measuring a proportional angle of theta over 2 pi. So we have to multiply by theta over 2 pi. And now we have lots of pleasant cancellation, and we're left with r theta. So here's your fundamental formula. The length of that arc of the circle is r times theta. Let me savor that for a moment. R times theta. So imagine a circle. Here's a circle. What makes a piece of arc big? Well, there are two things that could make it big. One is the circle could have a big radius, and then it would have a big arc. Or the angle that you're subtending, that cutting off, could be a big angle, and that would also make it a big arc. So both r and theta play a role in calculating that length of the piece of the circle. Okay, so it's kind of a nice formula. Let me make one more comment about radian measure. Sometimes you'll see an expression like theta equals 2, theta equals 5, theta equals pi. Expressions like that, when there are no units mentioned at all, we understand that to be radians. Let me say it a different way. If you're using degrees, please say the word degrees. 12 degrees, 17 degrees. But if you just tell me 12, then I'm going to assume you're doing it in radians. And that's